Hello everyone, welcome back to my channel. I am A. Purnaseshan, student of SVC Bangalore, Department of Information Science and Engineering, USN 1VE 22IS 001. Today, the main topic of our presentation is Introduction to Unix Operating System, Components and Architecture. Let us see the introduction to Unix operating system. Unix is an portable, multi-user and multitasking operating system developed by Ken Thompson and Dennis Ritchie in Grave Labs. Unix can run on various hardware platforms, enhancing its versatility. Supports multiple users accessing the system concurrently, promoting collaboration. Allows multiple processes to run simultaneously, improving efficiency. This makes Unix operating system very effective and efficient. Core components of Unix operating system are kernel, shell and file system. Let us discuss one by one. Kernel. Kernel is a core part of Unix that manages system resources including CPU, memory and devices. Shell. The command line interface that allows users to interact with the kernel and execute commands. File system. An hierarchical structure that organizes and stores files, making them accessible to users and applications. These are three core components of Unix architecture. Understanding the Unix kernel. It is nothing but process management, handles creation, scheduling, and termination of processes, ensuring efficient execution. Memory management allocates and manages memory space for process optimizing resource use. Device management facilitates communication with hardware devices through drivers, ensuring seamless operation. These are the main objectives and operations of Unix kernel. The role of Unix shell. Command execution. Users can run various programs and scripts through the shell, enhancing productivity. Scripting. Shell scripts enables automation of repetitive tasks, streaming workflows. Environment customization. Users can personalize their shell environment using alias and function for efficiency. Shell types. Common Unix shells include Bourne shell, C shell, and Bash shell, each with distinct features. Exploring the Unix file system. Unix file system consists of nodes, hierarchical structures, and permissions. Each file is represented by inode containing metadata and pointers to data. Process and process control in Unix. Process states. Process can be in new, running, waiting, or terminated states, indicating their current status. Process control block PCB. The PCB stores vital information such as the process state, priority, and memory usage essential for management of Unix operating system. Signals. Signals are mechanisms for inter-process communications allowing processes to send termination or suspension commands. Unix user and group management consists of user accounts. Each user is assigned a unique account with designated permissions for accessing the sources. Groups. Users can belong to multiple groups which enables collaborative accesses to shared resources. Permissions. Access to files is regulated through a permission system based on users, groups, and others. Networking in Unix. Unix networking is based on TCP/IP protocol, network interfaces, and remote access. TCP/IP protocol is a core suite for network communication, enabling reliable data transmission. Network interfaces allows configuration for connectivity to both local and remote systems. Remote accesses utilizes tools like SSH for secure remote logins and management. Unix security features are file permissions, user authentication, and firewalls and encryption. File permissions controls access to files and directories based on user roles. User authentication ensures that only authorized users can access the system. Firewalls and encryptions are used for protections and security of Unix features. Processes. A process is an executing instance of a program managed by Unix kernel. Unix allows multiple processes to run concurrently, supporting multitasking. Each process has its own memory space and can communicate with other processes through IPC mechanisms. Calls. System calls are interfaces that allow user programs to request services from the kernel. They provide essential functionalities such as file manipulation, process control, and network communication. System calls include open, read, write, and fork. In right side, you can see the image, how the system calls happen. Daemons. Daemons are background processes that run independently of user control. They perform various tasks such as handling network requests or scheduling jobs. Common examples include cron for job scheduling and SSHD for secure shell accesses. Utilities and commands. Unix provides a rich set of command line utilities to perform various tasks. Utilities like grep, awk, and sed are essential for text processing and data manipulation. Users can combine these commands using pipelines for powerful command line operations. Networking. Unix includes robust networking capabilities, allowing systems to communicate over various protocols. Tools like SSH, FTP, and Telnet enable remote access and file transfers. The architecture supports both client server and peer to peer networking models. Therefore, Unix architecture is modular and designed for flexibility and efficiency. Its components work together to provide a stable environment for multitasking and multi-user operations. A solid understanding of Unix components is crucial for effective system management and software development. Thank you.